here. I wish you all the best for 2026. In this video I will demonstrate how you can use QGIS, Blender GIS and Blender BIM to georeference models based on open software solutions. And for this case I'm using the tower of the Eiffel Tower in France and the Tower of Pisa in Italy. So here you see the Eiffel Tower as a model from the top, and for the map projections I use EPSG 3857. This is the coordinate systems that can be found in Blender GIS, but also in Google Maps, OpenStreetMaps, all kinds of mapping solutions. See Pseudo Mercator, WGS Worldwide Mapping System. If you look up in Google, you will find some maps, interesting maps, like this one. So this covers the whole world. That's a big advantage. Here you see the Eiffel Tower, and on the top screen you see the lot long value and the base map. So this is the line beneath is the WGS Pseudo APSG 35857. Also in QGIS you can do the same trick. So if you put the coordinate system to the right EPSG code, then you will retrieve XI in the bottom. Beneath here shows the XI value of this EPSG code. And as you can see, the lines beneath show exactly the same values as in QGIS, or as a matter of fact, every country has its own geoportal, which also shows these values. There isn't a spot on the earth that doesn't have any secrets what the XI value should be, or the lon lot value. As a first step, I need to write down these values. So for the first line for WGS 84 Pseudo Mercator, and the other one is the lon lot value. So if I want to use this in Blender GIS, this is Blender GIS, it's an add-on, you can find that and install it. So the first thing I need to do is relocate the model. Everything should be placed from the origin to the XI values of the Pseudo Mercator values. So I copy the first X value, and then I copy the second XI value, and the separator is the top in Blender GIS. And this way the model is being transferred away from the origin. Something went wrong. I'm doing it again. First the X value, then the I value. This is the I value. Put it there, top, second one. Okay, Z is null. Okay, and if you zoom out now, you will see that the model is far away from the origin. But this is done on purpose. Blender GIS will fix this. So the next step, what I'll do is copy the lon lot value as a whole, and I'll show you that it also works on Google Maps. If I copy paste this in Google Maps, the lon lot, I'll get exactly the spot on Google Earth. Maps. So Blender GIS works the same way. Activate the Google satellite, then press G for Google, the lon lot value, and enter 19 for the zoom value. This way you get a nice, zoomed in. So here again, the same values. You want to use decimal values. Decimal is the way these systems work, not with seconds. So as you can see, the Tour de Eiffel is positioned now on the right place. And if you look in Blender GIS now, okay, this is the Tour de Eiffel. The rotations is not being, it's the original rotations. But I should go to view, and there you see here you see the long lot values and these xi values. They correspond with the same web Mercator, the APSG code I referred to at the beginning. So, and now I can, in my IFC bonsai session, I can use these values. So the APSG code is the same, 53587, even kijken, 3857, 3857, and the easting, northing are these X values. So now my model is, as a IFC, is georeferenced based on pseudo Mercator with these values. So I put on these same values. It would of course be nice if Blender GIS and Blender BIM could have some more work better together more. I will foresee that this is coming if somebody programs it. This will become more easily. You don't have to type it over. But for now, it's these two are separated. But now I have this Eiffel Tower georeferenced, and well, that's okay. The same thing I'm doing with the Tower of Pisa. Of course, it's not so vertical challenged, so it's vertically a challenge. And well, I'm looking it up in different maps. The Italian map, which gives me the non-lat value. Of course, this kind of georeferences is not to the last meter. If you want to have more precision, you should use other kinds of geodata. This is based on photography, so it's about 2 to 5 meters accuracy. But I'm writing down these values again. So here you have Tower of Pisa, the pseudo Mercator, and the xi values. So same procedure. I'm copying the first x value of these WGS. I'm putting it now as a value of the object. It's kind of the same way as moving it. So I have one object, the whole tower. I'm putting it in place. Z value, okay, this doesn't matter for this example. And so it's moved now. You can see it on the right screen. I'm putting in, I'm activating Blender GIS now, base map, and I'm telling Blender GIS to go to the same place, 19 again, and there it is on the spot. And well, looks nice. Of course, it isn't 100% accurate, but that's very kind of difficult, especially using a tower like that. So okay, I'm really happy with it for now. You see the values, and that's being transferred now to Blender BIM, also known as Bonsai. As a matter of fact, a blender BIM shouldn't be called it that way. So easting, northing, filling in the values, and you're good to go. One last note. This is this shows the principle, but it's not 100% accurate. So for some purposes, you need more accuracy. So please be informed that you use other kinds of geodata for georeferencing, like the national factorized maps that are available for every country in the Europe or anywhere in the world, I think. So georeference the Eiffel Tower this way. Hope you enjoyed the video and you learned some things, and bye for now.